Hey everyone, and welcome to this explainer. Okay, I want you to imagine you're a digital detective, but instead of looking for muddy footprints or discarded receipts, you're tracking microscopic clues left behind by the actual physical hardware inside someone's computer. Today, we're exploring a fascinating 2026 guide that reveals something I honestly found genuinely shocking. Exactly how our web browsers are unknowingly volunteering our deepest hardware details to virtually anyone who asks. It's kind of unsettling when you stop and think about it, right? Is your own graphics card betraying your privacy? We usually think of internet tracking in terms of software, things like cookies or IP addresses. But modern websites, they've evolved way past that. They're actually tracking us at the physical hardware level now. Okay, let's dive into this and uncover exactly how this invisible surveillance operates. So, as our source outlines, this technique is known as WebGL renderer fingerprinting. Unlike traditional cookies, which, let's be real, you can just clear from your browser history in 2 seconds, WebGL fingerprinting relies on the unique physical characteristics of your graphics processing unit, your GPU. Originally, the WebGL API was just designed to bring cool 3D graphics into your browser, but it has inadvertently become one of the most powerful tracking vectors on the internet. It literally acts as an undeniable digital fingerprint. To break this all down, here is our roadmap for today. 1. The WebGL threat. 2. Anatomy of a fingerprint. 3. The spoofing dilemma. 4. The cloud solution. And finally, 5. Future frontiers. Let's get right into it. Section 1. The WebGL threat. The root of this whole threat lies in a very specific browser extension called WGL_debug_renderer-infer. And boy, does it eagerly volunteer your data. In fact, a specific renderer string exposed by this extension can instantly narrow your identity down to less than 0.5% of all web users. Just think about that. If you're running, say, an NVIDIA RTX 4070 on Windows, your browser essentially shouts that exact model name to the website, dropping you into an incredibly small, highly identifiable user pool right out of the gate. Now, what's really interesting about this slide is how specific these strings act as a prime suspect profile in our digital whodunit. An NVIDIA string doesn't just say NVIDIA. It gives the exact GPU model and the specific software backend. On the flip side, an Apple GPU string groups Apple Silicon users into a broader 15% pool. But if you have niche hardware, like a specific Intel UHD graphics card running on a Linux Mesa driver, you are immediately isolated into a tiny fraction of a percent. You're basically a needle that has magnetized itself so it can be easily yanked right out of the haystack. Moving on to Section 2, Anatomy of a fingerprint. Now, you might be thinking, well, what if I just block the exact name of my graphics card? Problem solved, right? Unfortunately, no. Trackers can build a complete profile without the name through a process called WebGL canvas hashing. Think of it like this. Imagine asking 2 different artists to paint the exact same bowl of fruit. Even if they use the exact same colors, their unique brushstrokes, the pressure of their hand, their blending techniques, those are always going to give away their identity. Fingerprinters do exactly this to your computer. They force your browser to render a hidden 3D test scene, extract the exact pixel data down to the microscopic level, turn that into a compact hash, and then compare it. The reason this actually works, and I found this absolutely fascinating, is because of microscopic hardware variations. Your GPU handles floating point math rounding slightly differently than mine does. The way it filters textures, processes anti-aliasing algorithms, and maps colors are all distinct. The source guide actually notes that even 2 graphics cards from the exact same manufacturer, right off the same assembly line, can produce unique pixel outputs. The canvas hash is essentially capturing the unchangeable physics of your specific microchip. And trackers dig even deeper than just looking at the pixel output. They actively query your vertex and fragment shaders to check your hardware's exact mathematical limits. By seeing precisely how your GPU handles complex floating point or integer math, trackers gather an additional 10 to 15 bits of tracking entropy. That is a massive amount of invisible data being used to build an undeniable, highly precise profile of your machine. Which brings us to Section 3, the spoofing dilemma. When people realize they're being tracked at the hardware level, their first instinct is usually to put on a digital mask, to just spoof their identity. But spoofing is remarkably tough. Trackers don't just look at one metric. They interrogate your browser's supported WebGL extensions. It's exactly like a detective checking a suspect's specific skill set. An older mobile GPU simply won't have the same high-entropy extensions as a modern desktop graphics card. So if you try to fake your identity, you have to perfectly fake the entire ecosystem of hardware capabilities. And this brilliantly illustrates why basic spoofing fails spectacularly. Imagine your browser tells a tracker, "Hey there, I'm an Apple M3 Pro chip." But when the tracker tests your math capabilities, your shader precision limits, it sees the distinct mathematical quirks of an NVIDIA RTX card. The tracker immediately catches you in a lie. You haven't hidden your identity at all. You've just loudly announced to a highly sophisticated anti-fraud system that you are actively trying to deceive it. To summarize the core argument from the guide, spoofing individual values inevitably creates detectable inconsistencies. Piecemeal faking of a WebGL fingerprint is not just ineffective anymore. In 2026, it is a guaranteed way to trigger modern anti-bot and anti-fraud systems. All right, Section 4, the cloud browser solution. So you're probably asking what actually works. Well, looking at this comparison from the guide, the problem with traditional methods becomes pretty glaring. If you just flat out block the renderer extension, that in itself is a giant red flag, creating medium detection risk. Injecting random noise into the canvas hash, that causes consistency issues and high detection risk. Even string spoofing fails due to the hardware mismatches we just talked about. The guide argues that the only approach right now with high consistency and low detection risk is utilizing a cloud anti-detect browser. So the crucial point is how these cloud solutions actually operate. The guide highlights a platform called Sendwin. Rather than trying to put a mask on your local hardware, this approach runs your browser profile on a remote server using a genuine, standardized cloud GPU. Because the browser is running on actual physical hardware in a data center, the renderer string perfectly matches the canvas hash, which perfectly matches the shader precision. The whole shebang lines up. There is zero spoofing involved, which means there are zero inconsistencies for trackers to flag. Finally, Section 5, Future Fingerprinting Frontiers. The tracking industry literally never sleeps, and this cat-and-mouse game is rapidly escalating as we move through 2026. Trackers are no longer just looking at what your hardware can do, they're looking at how fast and honestly how flawed it is. Advanced techniques now include rendering timing analysis, where they measure the exact milliseconds it takes to render a scene just to profile your processing speed. They're even using driver bug fingerprinting, intentionally triggering known edge case bugs in specific graphics drivers to see how your computer fails. That tells them exactly what software version you're running. And with the rise of WebGPU, a whole new architecture extraction surface is already emerging. It is a complex, highly technical battlefield happening silently in the background every single time you load a web page. We've seen just how deep the tracking goes, from the name of your card down to the microscopic math errors it makes, which leaves us with one final provocative thought. Are you ready to check your own digital footprint? Based on everything we've uncovered in this explainer today, what specific, unchangeable clues is your hardware leaking to the internet right now? Thank you so much for exploring this with us.